Hello Year 10 mathematicians. Just going to move on to the Year 11 book now. Unit 6 is a number chapter to start off with called direct proportion. And direct proportion is defined as when two quantities are in direct proportion then when one is multiplied or divided by a number, so is the other. So two quantities in direct proportion if when one is multiplied or divided by a number, so is the other. Now, there's lots of examples of this in real life. The most simplest example is just if you're in a shop and you have a product, let's say a calculator, and that is worth, say, £15. So the number of calculators I buy is one quantity, the total price is another quantity. The more calculators I buy, the more expensive my bill is going to be. And if I buy 5 calculators, then the price goes up by a factor of 5, assuming there's no deals or whatever. So that is this principle called direct proportion. When one quantity increases, the other quantity increases by the same amount. Or when one quantity decreases, the other quantity decreases by the same amount. That is pretty much it. Now there's some symbols you need to know. Which is the following. And this means y is directly proportional to x. Y is directly proportional to x. Now, this allows you to create a formula. Every single direct proportion question produces a formula, and the formula always looks like this. Y is equal to something times x. Y is equal to something times x. And that something depends on the question. Okay, so this is the formula for direct proportion. And the letter K in this varies on the question. The fancy word for it is the constant of proportionality, but you don't need to know that. But it varies depending on the question. Also, the symbol there is a Greek letter called alpha. Not a fish, but the Greek letter alpha. And that is just read as directly proportional, is what that means. So let's see what an example will actually look like. So you've got the extension y centimeters of a spring is directly proportional to the mass x kilograms hanging from it. So this is a physics question. It's actually something called Hooke's law. But yeah, in maths we're not going to call it Hooke's law. We just got the some numbers in there and we can create the formula without even knowing it's called Hooke's law. So given some information, which is the extension is 12 centimeters when the mass is 3 kilograms, and we're asked to find firstly a formula for y in terms of x. So the first thing you've got to do is rewrite this entire question in mathematical symbols. So extension y is directly proportional, this symbol, y directly proportional to x. So all I've done is concentrate on those key things to rewrite this as y is directly proportional to x. And then I need to know that this means the formula above. Y is equal to something times x, and that's something they use the letter k. So in other words, the formula is y is equal to something times x. Now, it's a little bit like equations of straight lines. This is a straight line, in fact. They don't use the letter M though, but they use the letter K, but they are equivalent to each other. But you have to work out the letter K. There's enough information for you to work out the letter K in the question. And that is this bit. Okay, so this information is used to find K, which is the constant of proportionality. We replace the y with a 12, we replace the x with a 3, and if you solve this equation, you end up with k is equal to 4. So the formula is y is equal to 4x. The extension is equal to 4 times the mass. That is the formula. Part B. The extension when the mass is 7 kilograms, we're going to try and use this formula. So, in other words, the mass, which is x, needs to be 4. Y would be equal to 4 times 4, which is 16, and it's 16 centimeters. So you've got a heavier mass. Sorry, I've written this question down wrong. The mass is 7. 4 times 7, which is 28. That makes sense. So you put heavier mass on, the extension is going to be more, which makes sense. Part C. This time you want the mass that produces a 20 centimeter extension. In other words, y is equal to 20 in this case, to give you 20 equals 4x, which gives you x is 5 kilograms. And that would be it. Now, the exam tip I'm going to give you for this is quantities in direct proportion also have the same ratio. Now what that means is, if I picked on pairs of quantities like I was given in the question there, and like I worked out in part B and part C, the ratio always needs to be exactly the same. And what I can do is, in this, just take y divided by x and work it out for every single pair. 12 divided by 3. The other pair was 28 divided by 4. Sorry, 28 divided by 7. And then this last one, 20 divided by 5. And all of these ratios are exactly the same as each other. They're all equal to 4. And if they weren't all equal to 4, then I've probably done the question wrong. Just realised I haven't shown you that. So all I did was take each pair, y divided by x, for the 12 centimeter and the 3 kilogram, for the 28 centimeter and the 7 kilogram, for the 20 centimeter and the 5 kilogram. All of those are equal to 4, which means I've done the question correct. If they didn't equal 4, then I've done something wrong, or the question isn't a direct proportion question. And that's always a check you can do to see if you've done this correct. And I've put the questions on the notebook.